Hello and welcome back to the Additive Snack Podcast. I'm your host, Fabian Alefeld, and today, in episode 4 of our medical series, we're shifting our focus to one of the industry's giants, Mark Morrison from Smith Nephew. With decades of experience in both additive manufacturing and material science, Mark is a true authority in that field. Together, we'll explore the significance of material science in additive manufacturing. We'll delve into Smith Nephew's journey and discover their achievements, including producing 100,000 patient-specific applications. Mark will also highlight the key applications driving AM adoption and the importance of porous structures in the medical space. We'll also touch on the patient-specific perspective, the challenges of integrating AM into big business, and how the industry is navigating the experience gap between traditional methods and modern additive manufacturing. So prepare for an enlightening journey into the world of medical additive manufacturing. Mark, welcome to Additive Snack.
Thank you for having me.
So Mark, you're one of the most experienced engineers and researchers in the additive manufacturing space when it comes to medical devices and the medical industry. How did you get there? How did you get into additive manufacturing?
Really by chance, honestly. We had a reorganization in research at Smith Nephew in about 2011. And I then just became responsible for our research in additive manufacturing, really just happenstance to some extent, and have been working in that area now since then, so about 12 years.
Awesome. Really good chance that you got in there. And you have a strong background in material science. How does that play into your work today? And also, why did you get into it?
That's a good question. So I, as a material scientist, I would say it's integral to additive manufacturing, whether it's polymers or metals or ceramics. And I think it was also one of the primary reasons that I was asked to lead our research on additive manufacturing in 2011 is because of that background. Mm-hmm. I got into material science because actually, just the introduction to material science class I had to take as an undergrad. It was Material Science 201. Mm-hmm. And it fascinated me understanding why materials behave the way they do, and how if you change the processing, you can change the structure, and that changes the properties. Just that understanding, which is really what drew me into engineering as well, is just understanding why things behave the way they do, mm-hmm. and how you can affect those things and mold them to what you want to some extent.
Yeah, and here additive also, I believe, is a very unique process that is able to change material properties as we go. Definitely. And throughout a print. So You're now at Smith Nephew, and besides yourself being one of the leaders in additive manufacturing, also Smith Nephew is one of the leaders in additive manufacturing and additive. What first got Smith Nephew looking into additive as a potential manufacturing technology?
I can't speak from firsthand knowledge, but we started in patient-specific instruments printed out of nylon, like a lot of the orthopedic industry did. I think additive manufactured had progressed as a technology, as a manufacturing method at that point, that it was viable to do this at scale in production. And so we got our feet wet there first with patient-specific instruments for knee arthroplasty. Mm-hmm. And really the only way that product across the orthopedic industry is feasible is through additive. For example, we've made hundreds of thousands of unique patient-specific instruments. Mm-hmm. Each case uses 2 instruments. So we've done over hundreds of thousands of those cases. And there's just no way you could feasibly do that economically other than additive manufacturing, because out of all those, none of them have been alike. It just wouldn't have been possible.
Yeah, for sure. And when did that journey start? How many years ago?
At least 2007, I would say. We launched, I think, that first patient-specific instrument around the 2008 timeframe, I believe.
Okay. Let me do my math here. More than 15 years, you guys have been in an additive manufacturing. What are some of
Correct.
the applications that we're seeing today that Smith and Nephew believes additive manufacturing can add value to?
Yeah, if you look at Smith and Nephew's products, other than those patient-specific instruments, if you look at both Smith and Nephew products and the industry as a whole, which is just about all the products that are out there to date involve a porous structure for cementless fixation or bone ingrowth. And that was really the driving factor initially for metal AM in orthopedics, because it allowed a lot of design freedom, as you often hear with additive, in terms of what does that porous structure look like, and therefore how does it behave and how does bone respond to it. It allows design freedom in what is the friction of that porous structure against bone. It helps to have high friction against bone to get good initial fixation when that implant is put in place in surgery. And then also it gives design freedom in terms of the device itself that might incorporate a porous structure. We were no longer tied to the paradigm that we had been in since cementless implants really started in the 70s, which is you have to first have a solid substrate, a device upon which you apply a coating with really limited ways of doing that. And so additive manufacturing really opened up that design space. And that's where Smith & Nephew, as well as all of our competitors in orthopedics, saw the initial beachhead or value proposition for additive. And then it's only grown from there. I would say it seems like the next frontier there is in patient-specific implants in particular. Again, just like the instruments, that's really only economically feasible probably by additive.
Okay. So the porous structures that we can create through additive manufacturing process are one of the key value adds that attract the medical industry towards additive manufacturing. What are the implications for patients out there, where today I get an additive manufacturing implant compared to a conventionally manufactured implant in the past?
That's a very good question. Ultimately, patient benefit is shown by clinical data, which we're gathering, but it takes a long time, unfortunately, because say hip and knee replacements, for example, work extremely well, even conventionally. And so it takes a long time to show a real clinical benefit to the patient of collecting clinical data and analyzing it and showing that. So I would say as a whole, it's probably still a little inconclusive, but we certainly have studies, for example, that suggest that bone ingrowth and fixation of an implant with an additive manufactured porous structure, if it's designed correctly, does result in that better fixation in bone ingrowth compared to a more conventionally made porous coating, let's say.
Yeah, and I could imagine that what you just mentioned earlier, that the trend of moving more towards patient-specific implants must have also an impact on patients down the road as well.
Yeah, I think it could very well. That's certainly the theory, is that what we've done since the beginning of orthopedics essentially is we make fixed sizes of implants and the surgeon makes the patient fit an implant. And what additive brings to the table with the possibility of patient-specific implants is to switch that around and make the implant fit the patient. It brings up new questions about how do you know what implant shape or design is best for a patient. So those are difficult questions to answer, and the industry is working on. But the hope is that by tailoring the implant to the patient, because all of us are different, right? On an anatomical basis, your knee is going to be shaped differently than my knee. And perhaps one day, with the benefit of additive, we'll look back and think it looked so archaic to have every person in the world with different ethnicities, things like that, genetics, that we picked one of 5 or 6 sizes and just made the patient fit that, as opposed to just say printing a device that perfectly fits that patient, that matches their anatomy, their soft tissue, etc. Yeah, maybe we'll get there one day with the help of additive.
Yeah, let's truly hope so. And additive, just like many other innovative technologies, really, it opens up a huge space of possibilities and opportunities that are oftentimes quite challenging for organizations to adopt and to integrate into existing processes. What are some of the limitations that additive manufacturing provides or deals with for medical organizations that we still haven't solved today?
I think cost is probably one of the bigger ones, because cost, everybody knows inflation has been pretty bad the last year or two. No different in our business. Everything we buy as raw material, for example, has gone up. And unfortunately, unlike maybe at the grocery store or a restaurant, we just can't necessarily freely increase our prices to accommodate that. But even before this, the last few years of inflation, it could be challenging to accommodate the higher cost that often comes along with metal additive manufacturing in particular. And so I think that has shaped the initial applications in orthopedics. I think it certainly has at Smith Nephew, as to where there is a value proposition to be made for additive in medical devices. For example, Smith Nephew started in revision hip arthroplasty. So revision hip arthroplasty, meaning the patient's already had one hip implant. It, for whatever reason, it has essentially failed and needs to be replaced. That second or third or fourth, if necessary, hip implant is called a revision. And so those are often difficult surgeries. They require a lot of building blocks and options to be available there in the OR to accommodate the surgeon and whatever he finds when he goes to pull that old implant out and put a new one in. And because of that complication, often reimbursement for those procedures is higher. And so therefore, because those reimbursements are higher, they're more complex cases, they can more easily accommodate, I would say, maybe a higher cost or price point associated with additive. But there are certainly a lot of applications, for example, where additive might be of value today in medical devices, but it's not being used because it just isn't feasible financially, let's say. That's the first hurdle I think about. And I think things are getting better every day. The industry is very focused on this. Powders, for example, have certainly come down in cost as there's been more competition to provide those, manufacture those, and sell them. Printers are getting faster, which helps with cost. So I think we're making progress there. The other thing that comes to mind when you ask about limitations or watchouts with additive is it's just so fundamentally different and new. And so there's a lot of just theoretical concerns about quality. The way I always address this or explain it is that collectively humans have thousands of years of history with casting metals, with forging, with machining. Yep. When contrast, we have about 25 years or so max, 30 now. If you go back to Chuck Hull in 1983, inventing vat photopolymerization. So compared to thousands of years, we have very limited experience with additive. And so and it's new, right? It's new to relatively new to medical devices. So there are certainly concerns where with conventional materials, we might order rods of Ti-6-4 that we receive in that have a certificate of conformance, very well documented. Again, thousands of years of history. We have decades of experience with buying titanium rod and machining implants out of that. So that's very comfortable for us, in other words, in terms of quality and known issues that we could run into. In contrast, additive, we're buying powder and we're converting that powder directly into an implant. There are no intermediate materials, raw materials, rod stock, et cetera, that we can characterize. And this conversion from powder to a near finished medical device takes place over, say, it could be anywhere from, say, 12 to 50 hours, depending on the printer, the height of the device, etc. And so you naturally wonder, how do I know that over those 50 hours that everything worked exactly as planned and that I don't have hidden porosity within this device in a really bad location and that would result in a failure? And so it's just, in my mind, it's the lack of experience in this area compared to conventional methods, and what could potentially go wrong theoretically, and getting comfortable with that with experience, which we've started to do, of course, but not everybody has direct experience with additive and feels necessarily comfortable with it at this point.
When it comes to qualifying additively manufactured implants, let's say, what role does the FDA play here to help organizations get through their certification process, really, to get a device on the market?
So when we started our journey, there was nothing from the FDA, really. We were left with using standards and FDA guidance documents that were drafted sometimes a decade or more ago for conventionally made materials. And so we had to guess as to how we should use those or adapt them to additive. And that caused a lot of heartburn and sleepless nights in some cases. Fast forward to today, now the FDA has progressed quite a bit. We have a guidance document that helps with that. So I think we're in a much better position today as an industry with experience and with things like guidance documents and increasing numbers of standards centered on AM that help us better clarify what does the path look like, both in terms of preclinical testing as well as in terms of quality control.
And if you now look at the whole medical industry, where are we in the adoption of additive manufacturing? Are we still just at the beginning, even though, frankly, the medical industry was actually one of the first industries to adopt additive manufacturing for true end-use parts? Are we somewhere in the middle? Where are we at?
That's a good question. I don't know, I guess would be the short answer. I would tend to say we're close to the beginning because it's been a relatively short period of time, right? Since it's 15 years, but in orthopedics, for example, our product life cycles are typically measured in several decades. So we're really just getting to maybe second generation AM implants in some cases in the orthopedic industry. So I would tend to say we're at the beginning. On the other hand, there's some people maybe think that one day we'll be printing everything. And I don't think we'll ever get to that point. I tell people that additive is a tool in the toolbox, just like a lathe or a mill. And I don't think we're ever going to get to the point where we print everything. It's a tool in the toolbox. It makes sense to use it in some applications and some it doesn't. I think the number of applications where it does make more sense will get broader in the future, definitely. But I think there'll always be a place for conventional manufacturing, say.
Yeah, I couldn't agree more. And I think that's a resounding opinion in the additive manufacturing space as well, that we will not replace conventional manufacturing. Neither do we want to replace conventional manufacturing. Right. It's a perfect match, actually, for many applications where I build near net shape and I machine certain surfaces afterwards. If we now look a bit into the future, you mentioned additive manufacturing has already progressed a lot. We were able to bring costs down significantly through hardware optimizations. Software is playing a bigger and a bigger role in optimizing not only the speed of additive, but also the quality assurance side of additive. What are you most excited about when you look into future applications, into future devices? Where are we not today, but where could additive manufacturing have a great impact?
Yeah, I'm most excited today about the various AM modalities that are really improving. We've been focused thus far on laser powder bed fusion primarily, But now you have modalities like binder jetting that are really showing a lot of advancements and a lot of new printer introductions. ED, I think, seems to be making a lot of progress. So, and then this is such a dynamic industry. It seems like almost every day I read about a new company or even new printing modalities that didn't exist yesterday.
Yeah.
And so to me, that's just very exciting to be on the cutting edge of such an innovative industry like AM. And that's what I really like about my job, is being at that forefront and looking for new applications where it could add value to our company and to patients ultimately.
Sure. And I think you just landed out perfectly. The additive manufacturing space can be very confusing, especially for folks who are just trying to get into it and are trying to understand what does additive mean for me and for my product and for my team and my organization. What kind of advice could you give somebody who may be in the medical space and is trying to understand how do we get into additive and how do we make the right decisions?
Yeah, that's a tough one. It is complex. I act basically as a liaison in my current job, or an evangelist, as another way to put it, for additive within the company, to educate people on what additive might bring in their applications, bring to the table. And a big part of that is understanding where might it make sense or be useful and where might it not. And it is very complicated. Just switching from one modality to the other, for example, let's say between powder bed fusion and binder jetting, the pros and cons of each are very different. The constraints are very different. So it's a huge learning curve to understand all of these intricacies. Even with, like I said, we could just take the difference between laser and e-beam powder bed, right? Much less going to DED or binder jetting, et cetera. And that's a huge challenge for people who aren't familiar. And I guess my best advice would be to identify someone who knows more than you do and ask them a lot of good questions.
Great advice, Mark. And it's also good to have somebody like yourself and like Smith Nephew who walks up front and shares some of your experience and your knowledge with the world, really, and hopefully can give some other folks some inspiration and some ideas on where additive manufacturing might be a great fit for them. So, Mark, I want to thank you for sharing all of your expertise with you and with us. And yeah, thanks for being on Additive Snack.
Thank you for inviting me. I enjoyed it.
Wow. That brings us to the end of another insightful episode in our medical series. A big thank you to you, Mark, for sharing your vast knowledge and giving us such a comprehensive look into the world of additive manufacturing at Smith Nephew. It's so fascinating to see how the industry is innovating and adapting and really bridging the vast experience gap between age-old practices and the nascent world of additive manufacturing. So as we continue our journey throughout this series, we're really reminded on a daily basis of the boundless potential and transformative power of additive manufacturing, especially in healthcare. So to you, our listeners, thank you for being a part of this exploration. I'm Fabian Alefeld, and this has been the Additive Snack Podcast. I'll see you next week in our final episode of our medical series.